Assalamu alaikum dear students. Welcome to Dr. Roomi's lectures. Today we are going to study a very important topic from neurophysiology, and this is classification of types of nerve fibers. There are two important ways by which we can classify nerve fibers. One is the classification called as general classification. It was described by Erlanger and Gasser classification or the general classification of nerve fibers. There is another one which is called as sensory classification. This is used by the sensory physiologists, and this was described by Lloyd and Hunt. So this is called as Erlanger and Gasser system of classifying the nerve fibers, and this is called as Lloyd and Hunt system of classifying the nerve fibers. When you studied nerve and muscle physiology, at that time compound action potential was discussed, and you learned that in a mixed nerve like in sciatic nerve there are three types of nerve fibers: A, B and C. So on the basis of those three types of nerve fibers, which are A, B and C type of nerve fibers, we have classified nerve fibers. The A nerve fibers and B, they are myelinated nerve fibers, and type C is unmyelinated type of nerve fibers. So it means this Erlanger system of classification, it depends upon whether a nerve fiber is myelinated or unmyelinated, what is its diameter, and secondly whether it's sensory or motor or both. You see, in this Erlanger system of classification, a general system of classification, there are sensory, motor, and the third one is autonomic type of nerve fibers. So it means all the three types of nerve fibers, the somatic sensory, the motor type of nerve fibers, and the autonomic type of nerve fibers, all the three nerve fibers, they are included in this general system of classification. But in this sensitive classification of nerve fibers, only the sensory type of nerve fibers are present. This is one difference between these two. This A alpha type of nerve fiber, it is further divided into four types: A alpha, A beta, A gamma, and then A delta type of nerve fibers. We'll discuss all these types of nerve fibers one by one. So first of all, let's talk about A alpha type of nerve fibers. What about their myelination? Do they have or not? Yes, they are myelinated type of nerve fibers. Their diameter is 12 to 20 micrometers. So they have maximum diameter, and this is why they're also fastest in conducting the signals. The velocity of conduction is between 70 to 120 meters per second. It's such a fast velocity that in 1 second the action potential, the speed of action potential along these nerve fibers, it can cover whole of the ground of a football. So it's such a fast speed of conduction. And the nerve fibers which are present in A alpha, they are of two types. They are somatic motor neurons, somatic motor, and they are somatic sensory types of neurons. So two types: somatic motor and somatic sensory types of neurons. The somatic motor types of neurons, they are also called as alpha motor neurons. And you know very well that in our skeletal muscles there are two types of motor fibers which supply them. One is the nerve fiber that supplies extrafusal muscle fibers, and the other one is the nerve fiber which supplies intrafusal muscle fibers. These alpha motor neurons, they are the ones which make neuromuscular junction with the extrafusal muscle fibers. And the somatic sensory nerve supply is actually also called as the nerves for carrying proprioception. So what do you know about proprioception? The term proprioception means the sense of movement and position. Whenever your arms and legs are moving, the information about the movement and position of your arms, legs, hand and feet, that's conveyed along the nerve fibers, which are called as proprioceptive nerve fibers, and this sense is called as proprioception. There are two types of nerve fibers which carry proprioceptive signals. One of them is the primary efferent nerve fibers, primary efferents from muscle spindles. You see, muscle spindles, these are receptors present in our skeletal muscles which detect change in length of a muscle. For example, when we are lifting weight, so and when we are playing cricket, there is change in the length of muscle. So those changes in the length of muscle, they are detected by muscle spindles. And there are two types of receptors in muscle spindles. One is the primary efferent and the other one is secondary efferent. Primary efferent nerve fibers, they belong to proprioceptive category. And then there is nerve fibers which carry signal from Golgi tendon organs. So we can call them efferents from Golgi tendon organs. These are also the ones which carry proprioceptive signals. As I mentioned, the muscle spindle, it detects change in length of a muscle. You can see here there is an L in spindle. You can easily memorize it, that the function of muscle spindle is to detect change in length of a muscle. And there is a T in tendon. So the efferent nerve fibers from the Golgi tendon organs, from these receptors, the sensory nerve fibers, they detect change in tension of a muscle. So T for tension and T is also for tendon. So these are easy ways to remember which one is carrying which signals. So from the muscle spindle, the signals of change in length of the muscle. From the Golgi tendon organ receptors, the efferent nerve fibers, they carry change in tension of a muscle. And these nerve fibers, they can also be put here under sensory classification. And in sensory classification, the primary efferents from the muscle spindle, they belong to category 1A. And the efferents from the Golgi tendon organs, they belong to category 1B. You can see here that in general classification of nerve fibers, there are letters A, B, and C. So this is a lettered nomenclature in general classification or the Erlanger system. In case of sensory classification or Lloyd system, the nomenclature is Roman numerals. So you can see here the Roman numbers 1, 2, 3, and 4, they will be used to represent the sensory nerve fibers. What about alpha motor neurons? I will put nothing here, which means that these alpha motor neurons, because they are motor, so they don't come under sensory category. Now I will make your life easier. It's a little bit confusing and difficult topic for the students, but this is a high yield topic when you will be studying sensory and motor physiology. In different topics you will come across these nerve fibers, so it's very important for you to memorize these nerve fibers, their diameter, their velocities, and their examples. But in order to memorize it, you need to know some important mnemonics and also some easy ways, just like I have given you the information that the Golgi tendon organs, the T is for tension. So the nerve fibers from here, they detect the signals of change in tension of a muscle. And this muscle spindle, it has L in it, and L is for change in length of a muscle. So the efferent nerve fibers, which are primary efferents, they detect signals of change in length of a muscle. These are also called as spiral nerve fibers in a muscle spindle, which are present around a muscle spindle, spiral nerve fibers. Later on, when I will teach you stretch reflex, at that time you will study that the primary efferent nerve fibers, they are also called as spiral nerve fibers. In Guyton physiology, at some places you will see that their diameter has also been mentioned, and their exact diameter for one A type of nerve fiber is about 17 micrometer, and the diameter of one B type of nerve fiber is about 16 micrometer. And you can see here that these two diameters, they come under this range of 12 to 20 These nerve fibers, they are widest in their diameter, they are myelinated, and because of these two properties, they are very fast to conduct. So their velocity of transmission or conduction along the nerve fibers is very fast. Now, how to remember which nerve fibers come under A alpha category? Okay, you have heard about alpha males. Alpha males are those who are very powerful males. Let's suppose they are interested in driving some kind of motorbikes. So the word motor is for motorbikes, and the word motor here is to represent alpha motor neurons. And also some powerful males, they acquire businesses and they run some property businesses. So the word here proprioception, that can be analogous or can be compared to the word proprietor, the proprietor of businesses. So that alpha male who is having who's very wealthy are running some businesses. So proprietor are the owner of some businesses. So that can be compared to the word proprioception. So the alpha motor neurons, I mean compared to the motorbikes and the proprietor, the owner of business. This is the properties of that alpha male. So in this way, you can remember what are these nerve fibers and what are their important functions. A beta nerve fibers, their diameter is about 5 to 12 micrometer, and the velocity of conduction is between 30 to 70 micrometers. They are also myelinated nerve fibers. In order to understand the sensations which are carried by A beta nerve fibers, let's take the example of beta. In Urdu, beta is the word which is used for son. Let's suppose your beta is not listening to you. He's a very naughty boy. So what will you do? First, you may give a fine touch to your son. Beta, okay, you need to improve. If your son is not listening, you may do a little bit more like tapping, so vibration as well. And if not listening after stressing, then you may need to put some pressure. So the signals which are carried by a beta types of nerve fibers, they are fine touch you're giving to your son, then some tapping, the vibration, and then some pressure. Okay, so these kind of signals, they are carried by A beta types of nerve fibers. Another very important signal carried by A beta types of nerve fibers is the secondary efferents from muscle spindles. So I have already mentioned muscle spindles. These are receptors to detect change in length of a muscle. They have two kind of nerve supplies: the primary afferent nerve signals, which belong to category 1A, and all these nerve fibers, they belong to category 2 under sensory classification. And all these signals, they are carried by A beta types of nerve fibers. These secondary afferent nerve fibers, which are detecting signals from the muscle spindles, they are also called as flower splay endings. So keep in mind, you may get this MCQ in your examination. The primary afferents from the muscle spindle, they are also called as annulospiral nerve fibers, and these secondary afferent nerve fibers from the muscle spindle, they are also called as flower spray endings. We will study them in detail later on when we will study the stretch reflex. A gamma nerve fibers. You see, A gamma nerve fibers, they are purely motor types of nerve fibers. So it means they will not come in this sensory classification. A alpha types of nerve fibers, they are both sensory, they are both sensory as well as motor. A beta, yes, they are only sensory nerve fibers. A gamma nerve fibers, they are purely motor types of nerve fibers. What about the myelination? Yes, they are myelinated. Their diameter is 3 to 6 micrometers, and the velocity of conduction is from 15 to 30 meters per second. What is the function of A gamma types of nerve fibers? They are motor neurons. They are they are gamma motor neurons which excite muscle spindles. Muscle spindles. You see, muscle spindles, because they're involved in controlling, responding to change in length of a muscle, The sensory signals from the muscle spindle, they are carried by the primary afferent and secondary afferent types of nerve fibers, and the motor signals coming to muscle spindles, they are called as gamma motor neurons. These are also called as the motor neurons to the intrafusal fibers, because the muscle fibers which are present in the muscle spindles, they are modified type of muscle fibers, and we call them intrafusal muscle fibers, which are supplied by the gamma motor neurons. So they cause excitation of the intrafusal muscle fibers. In Guyton, their diameter is mentioned to be about 5 micrometer, which comes in this range. How you can memorize the function of gamma motor neurons? Let's suppose a person is singing a song. You see, in Urdu, uh, song singing a song is called as Gana. So this is gamma, and from gamma, Gana. So let's suppose some person is singing a song, and when someone is singing a song, his hand is like this. Hand is like this. So when someone is singing, you see your arm is in tone. So these gamma motor neurons, they are involved in maintaining tone of a muscle, which is the function of the muscle spindles. And because muscle spindles, they're intrafusal fiber, they're supplied by the gamma motor neurons. So by exciting the intrafusal fibers are present in the muscle spindle, the controlled tone of a skeletal muscle. Now coming to A delta type of nerve fibers. They are also myelinated. The diameter is between 3 to 5 micrometer. The velocity of conduction is between 12 to 30. What are the types of signals which are carried along A delta types of nerve fibers? The signal carried are crude touch and crude pressure. You see, fine touch and fine pressure is carried by A beta types of nerve fibers. A delta carry crude touch, crude pressure. They also carry the signals of cold, so cold temperature, and also fast pain. You see, there are two types of pain: fast pain and slow pain. Fast pain is like the pain of a pin prick, or when we have a cut with a sharp knife. So that kind of pain, which travels faster, is carried by A delta type of nerve fibers. So the cold signals, they are carried by A delta nerve fibers. Crude touch carried by A delta, fine touch carried by A beta. Crude touch and crude pressure by the A delta types of nerve fibers. So let's suppose the same person who was singing a song. Okay, in this case, A gamma fibers, Ghana. So the same person who was singing a song, when he was involved in singing, he was so busy that he was not worried about anything, whether it was cold in the environment, he was having some kind of, pinprick, or there was some cold, crude touch or pressure, because he was so much interested and involved in his singing. So in this way, you can memorize the function of A delta type of nerve fibers. Yes, there are also sensory types of nerve fibers, purely sensory nerve fibers. So we will give them a Roman numeral, and that is number 3 in sensory classification or Lloyd system of classification. What about B type of nerve fiber? These are purely motor fibers, so they won't come under sensory classification. They are myelinated types of nerve fibers. What about their diameter? The diameter is less than 3 micrometers. And these nerve fibers, the velocity of conduction is between 3 to 15 meters per second. What is the example of these nerve fibers? They are preganglionic autonomic nerve fibers. When we studied the organization of nervous system, at that time I explained you that there is one sensory division and motor division. In motor division, there is a somatic division and then autonomic division. In autonomic division, there are two types of nerve fibers: preganglionic and then postganglionic type of nerve fiber. So this preganglionic nerve fiber, that comes under B type of nerve fibers. What about C nerve fiber? They are not myelinated. They are not myelinated. So these are the only nerve fiber which are not myelinated. Their diameter is minimum. So that's why the velocity of conduction will also be slowest. So how much is the diameter? Between 0.5 to 1 micrometer. And the velocity of conduction is also close to 1 meter per second. It may be less than 1 meter or close to 1 meter per second. B type of nerve fibers, they are autonomic motor. And here C type of nerve fibers, they are also autonomic and sensory as well. So it means there are two types of nerve fibers which are present in C category of nerve fibers. So first I will talk about the autonomic fibers. Autonomic fibers here, they are postganglionic autonomic nerve fibers, because in case of autonomic nervous system there are two motor neurons in a series. The first one, it comes under B category, the second one comes under C category. So they're postganglionic nerve fiber. And how can you memorize them? You see, what comes before B or C? What comes before B or C? You see, B comes before C. So in this way you can easily memorize that the preganglionic autonomic nerve fibers which come earlier or before the postganglionic fiber. So preganglionic fibers, they belong to B type of nerve fibers in general classification, and C type of nerve fibers, they belong to postganglionic autonomic nerve fibers. There is another type of nerve fibers here which are sensory, and those sensory nerve fibers, they carry signals of crude pain, or sorry, slow pain. For example, if you are having pain in your abdomen, like some type of cramp or there is some headache, so this is slow type of pain. They also carry olfaction, so the signals of smell from the nose, and they also carry signals of heat. So cold temperature is carried by A delta nerve fibers. You see, signals of heat or warmth, they are carried by mainly by type C nerve fibers. Why these C type of nerve fibers, they are very slow to conduct? It's because for these type of sensations we don't need a very fast speed of conduction. You see, smell, the signal of smell, they are carried by from our nose, and nose is so close to our brain. So even the smell signal, they are carried slowly, no problem. But you see, proprioception must be carried very faster. So the signal of proprioception from your toes, from your feet, must go to your brain very quickly so that some changes can be made if required when you're running very faster. So the A alpha type of nerve fibers, which include these proprioceptive fibers, they must be very fast to conduct, up to 120 meters per second. But these C type of nerve fibers, they are slow to conduct. Smell, we don't need very fast fibers, slow fibers. What about slow pain? If someone is having pain in his head for last 2 hours, so it will be connected slowly to our brain. All right, no problem. So slow pain is conducted slowly. Slow pain, olfaction and heat, they don't need the signals to be conducted at a faster speed, so they are slow as to conduct. But proprioception, that must be conducted very faster. These type of sensory type of nerve fibers, they come under type 4 of sensory classification, and these autonomic postganglionic nerve fibers, because they are autonomic and they are motor, so they don't come under this sensory classification. Now just to summarize, there are two ways to classify nerve fibers. One is general classification and the other one is sensory classification. In general classification, we have sensory fibers, motor fibers, and autonomic fibers. But in sensory classification, there is only one type of fibers, which are sensory fibers. And this classification of nerve fibers into two groups, in general and sensory classification, is on the basis of differences in the diameter of the nerve fibers and the presence or absence of the myelination. Bigger is the diameter and the myelination is present, then the velocity of conduction will be faster. And when there is no myelination and the diameter is less, the velocity of conduction will be slowest. So you can see here that type C fibers, they are slowest to conduct, and type A alpha nerve fibers, they are fastest to conduct. So when you come down, you can see here the diameter of the nerve fiber from A alpha to type C is gradually decreasing, and same is happening with the velocity of conduction. So more is the diameter and myelination is present, velocity of conduction will be much faster. There is no myelination in our fibers and there is less diameter, the velocity of conduction will be slowest. Type A alpha nerve fibers, they are somatic motor as well as somatic sensory types of nerve fibers. The somatic motor, they are A alpha nerve fibers which supply the extrafusal muscle fibers, and somatic sensory, they carry the proprioceptive signals at the position. Primary efferents from the muscle spindles, which are annulospiral nerve fibers, they belong to A1A type of nerve fibers. So it means the A alpha can be classified into 1A and 1B in sensory classification, and 1B belongs to the efferents from the Golgi tendon organs. You see, Golgi tendon organ, T for tension, it controls the tension of a muscle, and L is present in spindle. So you can see here. So the muscle spindle is responsible for responding to change in length of a muscle. So you can memorize it easily. Like the alpha male, who's very powerful, is interested in driving motorbikes. So alpha motor neurons, they these are the nerve fibers which come under this category of A alpha types of muscle fibers. And somatic sensory nerve fibers, their function is also proprioception. The function is proprioception. So you can take this word from here, prop. So this is like someone is who's very powerful alpha male is interested in running some businesses. So he's the proprietor or owner of some businesses. And the type A beta nerve fibers. So we sometimes give a fine touch of vibration, tapping, and pressure to our son who is very naughty and not listening to us. So beta similar to beta in Urdu, which is the word for son. And A gamma nerve fibers, gamma, like someone is singing a song, Gana in Urdu, and when someone is singing a song, his hand is like this, and the hand is arm is in tone, and that tone in the muscle is controlled by the gamma motor neurons which supply the intramufusal muscle fibers. So the muscle spindle have their motor supply from the gamma motor neurons, and muscle spindle have their sensory nerve supply along the primary afferents, which are 1A type of nerve fibers, and secondary afferents, which are type 2 nerve fibers. The A delta nerve fibers, they carry crude touch, crude pressure, cold, and fast pain. You see, heat signals, they are carried by type C nerve fibers, slow pain by type C nerve fibers, but the fast pain by A delta nerve fibers. And because B comes before C, so you can memorize it. The preganglionic autonomic nerve fibers, they belong to P category of nerve fibers, and C type of nerve fibers, they belong to postganglionic autonomic nerve fibers. So you may get different type of question in your exam, and you must not be confused in answering those questions. For example, if you get this question, which nerve fibers carry the sensation of proprioception? What should be your answer? The proprioception is carried by, you can see here, primary afferents from the muscle spindle, which are 1A type of nerve fibers, afferents from the Golgi tendon organ, 1B fibers, and also secondary afferent nerve fibers from the muscle spindle, which are type 2 nerve fibers. If I ask you this question, which nerve fiber carry fast pain? The answer is 1A. Delta nerve fibers carry fast pain. What about the nerve fibers which carry temperature? The answer is the cold temperature is carried by A delta fibers, and hot signals, they're carried by type C fibers. Another question. What are the nerve fibers which have least diameter and least velocity? You can see here that the nerve fibers with least diameter and least velocity are type C nerve fibers, and the nerve fibers with maximum diameter and maximum velocity are A alpha types of nerve fibers. Another question. What is the speed of conduction in A alpha nerve fibers? And the options in your exam may be 100 meters per second, 50 meters per second, 30 meters per second, 20 and 10 meters per second. What is the answer? The answer should be 100 meters per second, which comes in this range. So you can get any question in your exam what is the function of this nerve fiber, what is the speed of conduction of this nerve fiber. And another question which you can get in your exam, why A nerve fibers are faster than C nerve fibers? So the answer is that because A nerve fiber they are myelinated and they're also having wider diameter as compared to C nerve fiber which are not myelinated and they are having a smaller diameter. Another reason for that is because A fibers they have to get they carry proprioceptive signals and the signal which must be carried very faster. But C nerve fibers they have to carry signals which must be conducted slowly. So there is no need to have fast conduction along C type of nerve fibers. So dear students, I hope I have made this topic very interesting and very simple for you. So with all the mnemonics and easy examples which I have given, it must have become very easy for you to memorize this topic. How this is very important topic, and when you will be studying sensory and motor physiology at several places, you will come across different type of nerve fibers, and these nerve fibers they're usually confusing because you are confused with their diameters, their velocities, their functions, their examples. Now in here in this diagram, I have given you quick summary of all these types of nerve fibers, their examples, their functions, and some easy mnemonics by which you can memorize all these types of nerve fibers. So thank you so much for watching this video. If you like this video, please subscribe to my channel and click the bell icon so that you can get all the upcoming videos. See you next time with another video.